Hey there, here we go into chapter 8. Oh my goodness, what a journey we've been on. And let's continue with this awesome calculus sauce, if you will. We've got advanced integration techniques, manipulating integrands. So what is that all about? This chapter is all about more ways that we can integrate functions. And so we're going to see all kinds of different functions, but basically the moral of the story here is you can manipulate the integrand. You can manipulate this thing in a multitude of ways. We're going to see all those ways in this chapter. We're going to go over why they all work. Let's get rocking and rolling. So in this first lesson, it's all about some very tricky manipulations. These are things that are not on the AB or BC exam, but many college calculus courses and many AB and definitely many BC courses, just not on the exam. So this says evaluate the integral. What does that mean? Well, that means obviously find the integral. So here we go. So 5x squared over x squared plus 9. We've got that the degree of the denominator is the same as the degree of the numerator. And actually, anytime the numerator degree is greater than the denominator degree, meaning the power up here is more than this, you can use long division. So we're going to use long division to manipulate this. Now, the whole point here is that all of our manipulations, that's the tough part. The actual calculus, the actual integrating is not bad at all. This is all about setting ourselves up so that we can integrate nicely. So what we'll do here is we're going to divide x squared plus 9 into 5x squared. That's what this says to do, right? This divided into that. So x squared goes into 5x squared 5 times. 5 times x squared is 5x squared. 5 times 9 is 45. And what you're always doing is you're subtracting what is left there. So we're going to subtract all of this from that value there. And we're going to be left with 0 from the 5x squareds and a minus 45. X squared can't go into 45, so that's our remainder. So overall, what we now have is you have that this function, 5x squared over x squared plus 9, is actually equal to 5 minus 45 all over x squared plus 9. Okay, so what does that do for us? Well, that is 5x squared over x squared plus 9. That's what we just found. So we're going to take this and we're going to integrate it. Very cool. So this integral is therefore equal to the integral of 5 minus 45 all over x squared plus 9, all of that dx. Okay, now how do we deal with this? Now you don't have to split into two integrals, but I'm going to do that for the purpose of just explanation. This is equal to the integral of 5 dx minus, and what I'm going to do here is I'm going to factor out a 45 from this. And that's going to be 1 over x squared plus 9 dx. Ah, well, this is an easy integral. That's 5x. That's the whole point of us doing this integration. This integral right here, that's arctan, right? And if you're like, wait, arctan, what? Go back to chapter 5 if you're like, I don't recognize this as arctan. Now, remember that when we do arctan, what I like to do is I like to set what u is and what a is. So arctan overall, we've got the integral of du all over, and it would be a squared plus u squared, a squared plus u squared. And that's going to be equal to 1 over a arctan of u over a. And if you don't remember that again, check out that earlier lesson. Now, we're going to have a negative 45 just kind of hanging out. Then I need the integral of this. Well, that again, u is going to be equal to x. A is equal to 3 because this is essentially 3 squared. So you end up with negative 45, the integral of du all over, if u is equal to x, du is equal to dx, du over u squared plus a squared, or a squared plus u squared. We'll reverse it up. And that's going to give us the arctan that we need. 5x minus 45 arctan, or tangent inverse, of u over a, or x over 3. And of course, don't forget that that has to be over a, which is over 3. So that 1 over a part is this piece over there, and that simplifies down to 5x minus 15 arctan x over 3. And let me remind you, you can always take the derivative of this. And when you take the derivative of this, you'll end up back here. And then when you join that back up with a common denominator, you'll be back there. So long division is a great way to split things up when you have a degree in the numerator that is equal to or greater than the degree in the denominator. Now there's another way we could have done this problem. and I want to show you a different way to, well, manipulate. That is adding 0. And you might be like, say what? Well, check this out. You might not have ever thought to do this before. It's a very cool manipulation. I'm going to factor out the 5. And now what we have is x squared over x squared plus 9. Urgh. What do we do with that? Well, I really wish this was x squared plus 9 up top. So let's make it happen. So what you get is 5 times the integral of x squared plus 9. But you can't just make it x squared plus 9, right? You can't look at that and be like, oh yeah, I'll keep it plus 9. That'd be changing the problem. You can add a 9 if you also subtract a 9. So what we just did is we added 0. 9 minus 9 is 0. This is still equal to x squared. You're allowed to add 0 to something. It's strange to do, but it actually leads to some wicked cool manipulations in calculus land. So now that that's still equal to this, watch what we can now do. You get 5 times the integral of x squared plus 9 over x squared plus 9. We're going to split up the fraction over x squared plus 9. Minus 9 over x squared plus 9. Oh, isn't that cool? I think it's pretty rad. So we have all of this right here. Not so bad. So we've got all of that, and that actually reminds me of this error here. This is a negative there, right? So you always want to keep that negative always right there. And I know I switched back. You always want to make sure that you're keeping your signs throughout. I forgot to mention that, which we did here. All right, anyway, back to this. Back to this last problem that we were on. Let's check it out. So now that I went back on that minus problem just to show you how it's similar to this last problem, let's keep going. So I've got 5 times, well, this is going to be the integral of 1, and then this is going to be minus 9 over x squared plus 9. Now I'm not going to finish integrating this out because watch what happens. If I put the 5 into there, look what we end up with. 5 minus 5 times 9 is 45 over x squared plus 9. Is that or is it not what we had, and I'm going to switch back to the last page, on that last problem? It's exactly what we had right here, 5 minus 45 over x squared plus 9. It's just a different way of getting there. And so our answer is going to be the same exact answer. We know that from before, from the last page, which is 5x minus 15 arctan of x over 3. Isn't that a beauty? Oh, I think so too. All right, so we'll leave that problem alone, but adding 0 is a way to go. It's a neat manipulation. If you're like, yeah, you know what, I'll take long division, I'll stick with it, that's fine too. Whatever way you're going about it, I hope you had fun with this one. I know I did. Always do. See you next time. Peace.